All right, this is a problem from Openstax Calculus Volume 1 and Section 3.3. What we have is this figure which shows the graphs of a function f, and that graph is in red, and then a function g, and that graph is in green with dots. And we're going to assume that h is the product of these two functions. And we're going to find h prime of 1, h prime of 3, and h prime of 4, provided those derivatives exist. So let's start off with our solution where we find h of x prime. Well, that's going to be using the product rule. So we have f prime of x, g of x, plus f of x, g prime of x. That's the product rule. We take the derivative of the first factor. So we have a product of f and g. Take the derivative of f and leave g alone, plus leave f alone and take the derivative of g. For a, we are going to put in 1 for x, and then figure out what's going on there. So we're going to put 1 in for x for the derivative. Now, in order to do this, now I need to maybe make a little table or chart or something where I write down what f of 1 is, what f prime of 1 is, g of 1, and g prime of 1. Okay. Well, I think everything's right, but I'm trying to see how I'm going to fit everything in here. So, all right. Now, what's f of 1? Well, I'm going to, I suppose, start at x is 1 and just go up to f. And then my program went crazy here on the iPad, but okay. Probably the program's fault. Okay, then I go up, x is 1, and I go up and find f, and so that apparently is equal to 3. I don't really want to leave that line there for very long, but oh well. Now, what's the derivative? The derivative is the slope of the tangent line, but since it's just a straight line, the tangent line and the line are the same at that point at 1. And so 1, maybe I'll draw a little right triangle so I can see what the slope is, but it looks like I'm going down 1 and to the right 1. So the slope is -1 over 1, so that's -1. Okay, so that's the slope. The derivative is the slope of the tangent line, and since this function f is a straight line at 1, it's the slope of the line. And then for g of 1, I'll do something similar. I don't know, just go up here from 1 and I connect at 1. So g of 1 is equal to 1. And g prime of 1, well, what's that? It's the slope of the line, so I can maybe draw a little right triangle if that helps, but I don't think you really have to do that. You're going up 1 to the right 1, so you get 1. So now, with that information, I can fill this all in. F prime of 1 is -1. G of 1 is 1. F of 1 is 3. G prime of 1 is 1. So this makes -1 plus 3, which apparently is 2. If I did everything right. I guess maybe I could look that up in the solution guide. All these are odd problems, so you can look in the back of the open source textbook. It's all free to look at Openstax. So these are just the solutions. Now for B, I put in 3 for h prime. So I'll have f prime of 3, g of 3, plus f of 3, g prime of 3. Now I have to make a similar chart. Okay. So f of 3 is what? What's f of 3? Well, let's see, let's just go up here. F of 3 is equal to 1. But what about f prime of 3? F prime of 3 is undefined. Why is that? Because the graph has this sharp edge. Some textbooks call that a kink. A sharp edge. And so it's undefined. Or no, actually, sorry. Undefined is not really the right word. The right word is does not exist. It's not quite the same thing. It's not, undefined is not correct. Does not exist is correct. Or maybe anyway, I'm going to write does not exist. So I don't want to quibble about that, but I'm going to write does not exist. And the reason is because I have this sharp edge. And, if you came from we've talked about that before, so I'm not going to keep going over that. G of 3 is not really necessary to determine since we're sort of already came to a stop there, but I will just write it down anyway. G of 3 appears to be around 2.5. G prime of 3 is, again, the slope of the tangent line, and the slope seems to be 0 because it's horizontal. I mean, it's 0, okay. But when we come to this problem, I'm going to write down that this does not exist because okay, over here, there's a kink in the graph or sharp edge. All right, I'm going to write it does not exist. And the reason is because of this f prime of 3. That's the sort of causing us trouble there. Or is it trouble? Maybe it's good not to exist. Okay, anyway, that's why it doesn't exist. And then for C, I look at h prime of 4, and I'm going to move things over. Okay. So again, I'll just put in 4 for everything. So I have f prime of 4, g of 4, plus f of 4, g prime of 4. So I'll just work on all of those. And it's easier if I make this bigger. So let me just go ahead and do that, and I'll come back to below, writing that stuff below. It's easier to see probably if I have it bigger though. Okay, so now for f of 4, same stuff. I'm going to go at 4. I'm going to see that the y-coordinate f at 4 is 2 apparently. I keep saying apparently, but anyway, I look at it, it looks like it's 2. All right, the derivative is the slope of the line, which is 1. Why am I saying it's 1? Because if I draw a little right triangle, I see that the rise is 1 and the run is 1. So 1 divided by 1 makes 1. So you can do 1 over 1 makes 1. G of 4 is then the y-coordinate of that function g. It looks like it's 2.5. I don't know why they didn't put it on anyway something else so it comes out nice and evenly, but that's all right. Okay. And then the derivative is 0 because that's the slope also, and it's a horizontal line. Horizontal lines have slope of 0. And so then I just fill in all those numbers. I put in 1 for g f prime. For g of 4, I put in 2.5. For f of 4, I put in 2. For g prime of 4 is 0. So that makes 2.5. And that's the answer there. That is problem number 131. Now, there's also problem 132, which is really similar, and we can work through that. I don't want to, truthfully, I'm sort of getting tired of doing this, so I don't want to make the video too long, but it's really similar because we have so much of this data already. But, you know, all this stuff up here where we plugged it, you know, we found all those values at 1, 3, and 4 was a bit of the work involved. So if I can use that, I can work on these problems here. So let's do on the 132. 132, the problem is h is f divided by g. So to do this problem, when I have h is f divided by g, I'll use the quotient rule. So f over g prime of x is going to be the numerator derivative, and then it's going to be f prime times g. F is in the numerator, we take the derivative of that first, then we multiply by the denominator. Then the numerator stays the same, take the derivative of the denominator, and then you multiply by the denominator squared. Sometimes people ask me why I pick different parentheses in the denominator. I just do it because I thought it looked all right to do it that way. But then, so this is h prime of x. So h prime of x equals this. All right, so h prime of 1 is then f prime of 1, g of 1, minus f of 1, g prime of 1, over g of 1 squared. All right, so this is referring to the same picture, and I'm going to use that same data. I know that when I zoom out, it's harder to read, but anyway, I don't want to, anyway, I got to use all that data that I had before, and I'm just plugging in all those numbers that I wrote down that's now sitting in an orange box. But since it's sort of far away, and I had this idea that I was going to do this faster because I feel like I'm already done, almost, or done most of it, that's possibly where I'll make a mistake. But anyway, hope I don't. But I'm using this group of stuff here that I'm putting a square around. That's what I'm putting there. And so I could, just to make a bigger mess, like put little snail tracks over there. That's where I'm getting that. Let's put all that stuff in there. And so that's going to give -1 minus 3 over 1, which is -4. All right, so it's -4. Done with that one. All right, now move on to B. B, we're taking this h prime formula and putting in 3. And I guess what's going to happen is I'm going to have the same problem as before, that the derivative at 3 of f is undefined. So remember that, again, we had, I'll highlight it here so we can make sure we see it. But see, f prime of 3 does not exist. I said undefined again, the correct word I think would be does not exist. And again, that was because at 3 we have this sharp edge. So I'm going to go down here and just, for f prime of 3, that's undefined. And I'm going to say the whole thing's undefined. Does not exist. That's what I'm going to say, sorry. And I'll say because f prime of 3 does not exist. And then I keep thinking though, is there some way that you could multiply two functions where the derivative point doesn't exist and you multiply it and you get the derivative does exist? And I'm just thinking of all the possible cases, but I don't think that's going to happen here where you have the kink in the graph. So I'm not going to get into too much of that, but I'm wondering if I could, sit around and think about some sort of unusual function when I take the product or the quotient, and then I do get something that doesn't exist. But let's not think about that right now, and just do this problem, because I think if you have a kink in the graph, no matter what you multiply by, you'll still have a kink, I think. Okay, so again, for this h prime of 4. Okay, actually I'm doing a redo of h prime of 4, so this part C. I had, I don't know, I just wrote down the formula wrong. I put the wrong numbers in. So for h prime, I'm going to use the formula that's given above, and I'm just going to copy and paste it correctly. But I am going to put in, instead of x, I'll put in 4. And I'm doing that right here. So I put in 4, and previously I put f of 4 in the denominator, which isn't correct. It's g of 4. And then I'm going to go ahead and put in f prime of 4 and all those numbers, which are way up here. F prime of 4 is apparently 1. G prime of 4 going all the way up to the top is 2.5. See, we have them all written down here. Okay, let me zoom in. We have f of 4, f prime of 4, g of 4, g prime of 4. I'm just going to put all those in there. So f4 is 2, f prime of 4 is 1, g of 4 is 2.5, g prime of 4 is 0. So let's see. F of 4 is 2, so I'll put minus 2, and g prime of 4 is 0. And in the denominator, I have g of 4 squared, so that's 2.5 squared. So I'm going to have 2.5 divided by 2.5 squared, and that makes 1 over 2.5. And that is the same as 1 over 5/2, which is 2/5. Okay, so that is the answer there, apparently. So, okay, that's all.